Hello students, and my name is Dr. Surendra, and let us today study about rate of reaction. We wanted to find out, sometimes we often get a feeling that which order reaction is fast and which order reaction is slow. And I asked many students, and sometimes they used to say that higher is the order and higher is the rate of reaction. And today let us solve through some thought process by considering the arbitrary reaction. So through some example, I'm going to show you today which are the important aspects to look at to find out which rate of reaction is faster. And let us start the class. And okay, how it looks. Let us consider this arbitrary reaction. Here is the reaction considering A gives rise to B, which is happening in a constant volume batch reactor. So the design equation for the batch reactor is dCA by dt is equal to RA. So this is the design equation for any batch reactor which operating under constant volume. And if I solve this design equation in terms of three different cases, one is, let us solve this equation in when considering the zero order, and the second case we are considering the first order, and third case we are considering the second order. And if we assume this particular reaction is of a zero order and the rate of reaction is minus K0 because there is no concentration dependency. And if in the case of first order, it is the concentration dependency of the order 1. If we consider this particular reaction, the concentration dependency of this reaction is of order 2. So if I substitute this particular rate in our design equation and integrate from initial concentration to final concentration, I can come to the conclusion is time for this particular concentration. What is the time required for the zero order? And then what is the time required for the first order and time required for the second order? These are the different times which will decide which reaction order is faster or which reaction order is slower. And let us consider the two cases. I am going to solve this particular equation by considering two different situations. Situation 1, that is case 1. If my initial concentration, assume my initial concentration 0.2 mole per liter, and for the time being assume reaction rate constant K0 is approximately equal to K1 is approximately equal to K2, which is 0.01. Let us find different times for different conversions. I wanted to find out time for achieving 10% conversion, time for achieving 50% conversion, and time for achieving 95% conversion. This is for the zero order. This is for the first order. And this is for the second order. And time required to achieve 10% conversion in a zero order reaction is 2 minutes. That is time. Now I'm calculating because I have done the background calculations. Time is in minutes. So time required to achieve 10% conversion for a zero order reaction is 2 minutes. For first order, it is 10.5. For second order is 55.5. Similarly, time required to achieve 50% conversion for the zero order is 10. It is 69.3 for first order and 500 for the second order. And time required to reach a zero order is 19 minutes for 95% conversion and 299 for first order and 9,500 for second order. By looking at this particular values, you can imagine that second order, I mean the zero order, within less time it is achieving this particular conversions. As you increase the order, you can see time required to reach this particular conversion is increasing. Imagine in case of zero order, it takes 2 minutes. In case of first order, it takes 10. In case of second order, it takes 55.5. Like for every conversions, even though for the 95% conversion, I can see the zero order within 19 minutes, it could able to reach 95% conversion. As you increase the order, the time required to reach for this any particular conversion is rising. So let us don't just come to a conclusion. That means zero order is fast compared to first and second. Let us take the consideration case 2. Case 2, let us take the initial concentration is 10 moles per liter. K0 approximately equal to K1 and approximately equal to K2 is equal to 0.01. Let us take the same case and solve the equations. Zero order, first order, second order. The time required to achieve 10% conversion for a zero order is 1000 minutes. Time required to achieve the first order is 10.5. Time required to achieve the second order is 0.11. Similarly, for time required to achieve 50% conversion for a zero order reaction is 500. Right. So 69.31. This is, you can imagine, point. And time required to achieve 99% conversion is 9900, 460, and 99. You can see, now you consider this case now. The moment I changed my initial concentrations by keeping the rate constants at the same value, the higher is the order, faster is the reactions. Imagine for 10% conversion, it takes 1000 minutes for a zero order reaction to reach to 10% conversion, 10.5 minutes to reach to 10% conversion for the first order, and second order, it takes just a 0.1 minute to reach to 10% conversion. And you can imagine it's all, I mean, you can see the case 2 has brought bigger change. That means it seems to be now second order is faster compared to the first and compared to the zero order. So never from this analysis, we can get to one conclusion, not to blindly depend upon to say that only second order is fast or zero order is fast. And the fastness and slowness of the system or a reaction depends on these two values. What is the magnitude of K we are taking? Magnitude. And what is the magnitude of the concentration we are taking? So the magnitude of K and Ca decides the fastness and slowness of the system. Because if you see here, the equation will react depending upon these magnitudes. For the first order, it depends upon the logarithmic ratio, because ratio, it won't feel that much change. You can see the for zero order, the magnitude will be different for different cases. And T2, it will react in this kind of equation, 1 by CAF minus 1 by CA naught. So the equation will react differently if my magnitudes are different. So never come to a conclusion. So always you have to look into the equation and magnitudes of the numbers we are dealing with, and thus you can come to one conclusion, which reaction order is fast. Thank you. That's for today.